Now let's discuss question number 35. This is the first question of section D, which contains 4-marker question. That means here we have long answer type questions. In this question number 35, we have got two choices where both of them are from the chapter of real numbers. Here in the first choice, it has been stated, show that the square of any positive integer cannot be of the form 5q plus 2 or 5q plus 3 for any integer q. And in the second choice, you have to prove that one of every 3 consecutive positive integers is divisible by 3. So let's proceed with the first choice. Here, as we have to show that square of any positive integer cannot be of the form 5q plus 2 or 5q plus 3 for any integer. So this is a question where we apply Euclid division lemma. So from this question itself, you get an idea that here we need to consider a positive integer, and we will be considering the positive integer to be a, and I'll be taking up b as 5. Why b as 5? Because in the question itself you get an idea that I have to show it is not in the form of 5q plus 2 or 5q plus 3. So I'll be taking b as 5. So by applying Euclid division lemma on a and b, considering that a is greater than b, I can definitely express it as a equal to 5m plus r, where m is some integer. So as you know, when you apply Euclid division lemma, you can express two integers as a equal to bq plus r, that is in the form of dividend is equal to divisor into quotient plus remainder. So here I am considering divisor as 5, quotient as m, any integer greater than or equal to 0, and r is the remainder. So remainder is always greater than or equal to 0 but less than the divisor. So here divisor is 5, so remainder will be greater than or equal to 0, less than 5. That means possible values for remainder will be 0, 1, 2, 3 and 4. So considering all these possibilities for remainder, we can express a as 5m or 5m plus 1, where I am taking r as 1, then further 5m plus 2 or 5m plus 3 or 5m plus 4. So these could be possible ways of representing this positive integer a. Next, as I have to show that square of this positive integer cannot be of the form 5q plus 2 or 5q plus 3. So let's consider a as these value one by one and try to prove the required condition. So very first, I am considering that a is 5m, and on squaring it up, I am getting its square as 25m square. You can see in 25m square, you can easily take 5 as common. So after taking 5 common, 5m square will be left, where I can consider 5m square as q. So it can be expressed as 5q. It cannot be expressed as 5q plus 2 or 5q plus 3. So considering now a as 5m plus 1. So when I consider here a as 5m plus 1 and square it up, on expansion it results 25m square plus 10m plus 1, where 5 can be taken common from the first two terms, which results here it in the form of 5q plus 1, where q is any integer. This whole portion 5m square plus twice of m can be considered as some integer q. So you can see this cannot be also represented in the form of 5q plus 2 or 5q plus 3. Next I am going to take up a as 5m plus 2. On expansion it results 25m square plus 20m plus 4. So here you can easily take 5 common from the first two terms, resulting here 5m square plus 4m, where this can be considered as any integer q, which gives me that square of this is represented in the form of 5q plus 4. It is not in the form of 5q plus 2 or 5q plus 3. So let's proceed ahead. Here next I am considering a as 5m plus 3. On squaring this, here it results 25m square plus 30m plus 9, where 9 can be splitted up and written as 5 plus 4. So you can easily take 5 common from 25m square, 30m and 5, resulting here in the bracket 5m square plus 6m plus 1 plus 4. So again this whole bracket can be considered as q, some integer. So this is represented in the form of 5q plus 4. So notice again here it is not in the form of 5q plus 2 or 5q plus 3. Further, finally I am considering a as 5m plus 4, and again on squaring it up, it results 25m square 40m plus 16, where 16 can be written as 15 plus 1. Now why we are doing so? Because we can take here 5 common from those terms. On taking 5 common, it results 5m square plus 8m plus 3 plus 1. Again this whole bracket can be considered as q, where q is any integer. So in all of these, we have seen here when a was 5m, in that case it was represented in the form of 5q, and when a was 5m plus 1, it was represented in the form of 5q plus 1. When it was 5m plus 2, its square was represented as 5q plus 4. When a was 5m plus 3, its square was again represented as 5q plus 4. And when a is 5m plus 4, its square is represented as 5q plus 1. In none of these cases, we figured out that a square can be represented as 5q plus 2 or 5q plus 3. So, it proves here the required condition that square of any positive integer cannot be of the form 5q plus 2 or 5q plus 3 for any integer q. Hence, we proved this required condition. So, this was a 4-marker question where you have proved the required condition. So, in this question, when you consider a and b, here in this step, till application of the Euclid division lemma, you get here half mark. For obtaining possible values of r and applying EDL, that is Euclid division lemma, you get half mark. And further, for obtaining possible values of positive integer a, that is 5m, so on till 5m plus 4, you get half mark. Next, here in this step, we get half mark for obtaining its square. In this step also, we get half mark. Next, in this step also, we get half mark. In this step also, we get half mark. And finally, on proving the final condition, we get here half mark, which gives me here total 4 marks for this question. I hope it is clear to you. Now, let's move to the second choice for this same question 35. So, here in the choice of this question, you have to prove that one of every 3 consecutive positive integers is divisible by 3. So, very first we need to assume 3 consecutive integers. So, most basic thing is to assume one of the integer as n, another as n plus 1 and another as n plus 2. So, 3 consecutive integers can be definitely considered as n, n plus 1 and n plus 2. Next, we need to prove here that they are one of these 3 consecutive integers is definitely divisible by 3. So, I am considering that this positive integer n can be represented in the form of 3q or 3q plus 1 or 3q plus 2 by Euclid division lemma. So, I can write here by Euclid division lemma n can be represented in the form of 3q plus r. As you know, r is greater than or equal to 0, less than the divisor 3. So, 3 possibilities for r goes like 0, 1, 2. So, taking that into consideration, I have 3 possible values of n, 3q, 3q plus 1 and 3q plus 2. Now, we will be considering here 3 cases. Very first case I will be taking up where n will be equal to 3q. So, if I consider here n is equal to 3q, then one by one I need to check here whether which of these will be divisible by 3. So, here n is 3q. So, this is completely divisible by n. So, n plus 1 will be 3q plus 1. This won't be divisible by 3 as I cannot take 3 common from both the terms. Next, you can clearly see when I have n plus 2, here it is 3q plus 2. So, it is also not divisible by 3. So, only one is divisible by 3, that is 3q. So, in this case n is divisible by 3, but n plus 1 and n plus 2 are not divisible by 3. Now, let us take up here case 2 where I will be considering n as 3q plus 1. So, when I consider here n as 3q plus 1, in that case I have n as 3q plus 1. Next, I have n plus 1 as 3q plus 1 plus 1, that is 3q plus 2. Next, I have n plus 2 as 3q plus 1 plus 2, that is 3q plus 3. So, you can easily take 3 common from this, resulting here q plus 1. You can clearly see 3 cannot be taken common from the first 2, but from here it can be definitely taken as common. So, in this case n plus 2 is divisible by 3, but n and n plus 1 are not divisible by 3. In similar manner, let us take up here case 3 where I am considering n as 3q plus 2. So, I have n as 3q plus 2, n plus 1 becomes 3q plus 2 plus 1, that is 3q plus 3, and here you can easily take 3 as common, resulting here q plus 1 in the bracket. And next I have n plus 2. Here I have 3q plus 2 plus 2, that is 3q plus 4. So, you can easily consider it as 3 times q plus 1 plus 1. So, you can clearly find in this case only n plus 1 will be divisible by 3 because 3 can be taken common only from n plus 1 in this case. So, in this case n plus 1 is divisible by 3, but n and n plus 2 are not. So, hence From all these cases, we draw a clear conclusion that 1 of n plus 1 and n plus 2 is divisible by 3 for any 3 positive consecutive integers n plus 1 and n plus 2. So in this way, we prove here the required condition. I hope this question is clear to you. So in this question, very first, when we have considered these 3 consecutive integers, for this step you will get half mark. Then for applying Euclid division lemma, you get here half mark. For the first case, obtaining this result, you get 1 mark. Next, for the second case, you get 1 mark. And finally, for the third case where you have concluded the required result, you get total 1 mark. So we get here total 4 marks for this question. I hope it is clear to you. Now let's proceed to our next question. So here we have question number 36. Now let's take up here question number 36. This question also has 2 choices. In the first choice, it states that the sum of 4 consecutive numbers in AP is 32 and ratio of the product of the first and last to the product of the 2 middle terms is 7:15. Find the numbers. And in the second choice, you have been provided with an equation where you need to solve this. That means here we have a known quantity x that needs to be determined. So both these questions are from the chapter Arithmetic Progression. So let's proceed with the first choice. As here, sum of the 4 consecutive numbers in AP is given. So what do we consider as the basic 4 consecutive terms in AP? You can consider them as A plus D, A plus 2D or A plus 3D. But it is always better and easier to calculate if we consider 4 consecutive terms in AP as A minus 3D, A minus D, A plus D and A plus 3D. So let's consider here 4 consecutive terms in AP as A minus 3D, A minus D, A plus D and A plus 3D. Next, as it has been clearly stated that sum of these 4 consecutive terms is 32. So let's add all these and equate it to 32. So according to this condition, we get the sum total as 32. So you can clearly see this equation is in terms of A and D, where you will find plus D minus D will get cancelled up and plus 3D and minus 3D will also get cancelled. So this equation will reduce to 4A equal to 32, which finally gives me the value of A as 8. So here I have obtained the value of A as 8. Next, I also need here value of D to get here these 4 terms of AP. So I'll be taking up here the second condition provided in the question, and second condition states ratio of the product of the first and last term to the product of 2 middle terms. Here I have first term A minus 3D and last term is A plus 3D. So I'll be taking product of these 2 and I'll be taking the product of these 2 middle terms A minus D and A plus D. Ratio of these 2 products is 7:15. So on basis of this, we generate here this condition that A minus 3D into A plus 3D upon A minus D into A plus D is 7/15. So as you have already figured out the value of A as 8, on substituting this, here we are substituting this from the help of equation number 1. A is equal to 8. On substituting this, we are able to generate here this equation as 64 minus 9D square upon 64 minus D square equal to 7/15. So further I need to cross multiply this, which gives me here 15 into 64 minus 9D square equal to 7 into 64 minus D square. So you need to simplify it, and on clubbing the like terms together, I'll be getting here finally 128D square equal to 512. So you can further simplify this. On reducing both the sides, I get here that D square is equal to 4. So I clearly get here the value of D as plus minus 2. So D is also obtained and A is already obtained as 8. Using this, I can definitely get the 4 numbers, that is the 4 consecutive terms of the AP. So next I could write, so 4 consecutive terms of AP are of arithmetic progression are A minus 3D, where A is 8, and if I consider here firstly D as 2, I'll be getting 8 minus 6, 2. Next A minus D, 8 minus 2, I get here 6. A plus D, 8 plus 2, 10. Then A plus 3D, I get here 8 plus 6, 14. Or else if I consider d as minus 2, then in that case I'll be getting here 8 plus 6, 14, then 8 plus 2, 10, then 8 minus 2, that is 6, then 8 minus 6, that is 2. So the same 4 numbers will be obtained, just order will reverse. So the required 4 consecutive terms of AP are 2, 6, 10 and 14. I hope it is clear to you. So this was a 4-marker question where firstly, on considering these terms in AP, I'll be getting 1 mark for this step. Further, on considering the first condition and obtaining here the value of A as 8, you get here another 1 mark. After that, you have been given with this condition where on solving this and substituting here the value of A, you get half mark, and further you get half mark for obtaining the value of D. And finally, for obtaining these 4 consecutive terms of the AP, you get rest 1 mark. That gives you total 4 marks for this question. I hope it's clear to you. Now let's come to the second choice of the same question. So in this choice, you can clearly see I have been provided with this equation where x needs to be determined. Here in this case, when I visualize here these terms of this equation, here I have 1 and 4. Difference between these two is 3. Difference between 7 and 4 is also 3. Difference between 10 and 7 is also 3. That means these consecutive terms are having a constant difference of 3. So these could be definitely the terms of an arithmetic progression. So I could definitely state here that on the left hand side, I have been provided with the sum of n terms of an AP, where x is the nth term. So let's consider here that 1, 4, 7, 10, so on till x is an arithmetic progression, as there is constant common difference between 2 consecutive terms. So x is the nth term here. I could consider here next, I have the first term as a and common difference d as 3, because the constant difference is 3 between consecutive terms. Next, I can take up that there are n terms in this arithmetic progression where x is the nth term. So further you can definitely solve this as nth term can be represented as a plus n minus 1d, where a is 1 and d is 3. So next, I could clearly get that on substituting a and d, x is equal to 3n minus 2. So here I have x equal to 3n minus 2 as equation number 1. X is obtained but in terms of n. That means in order to get the value of x, I need here the value of n. So I'll be taking up this equation. The left hand side represents sum of the n terms of an AP, which is equal to 287. So let's take up this AP and obtain the sum of n terms of this AP and equate it to 287. So taking that into criteria, sum of n terms of an AP can be obtained as n by 2 into first term plus last term. Here first term is 1 and last term is x, where x is definitely 3n minus 2. So this equation simplifies to this value, 3n square minus n minus 574. So you can see this has been simplified as a very basic quadratic equation, where you can easily solve this quadratic equation to get the value of n. So let's proceed with this equation. Here I have 3 and 574. On factorizing it, you can clearly see it can be easily factorized as minus 42n plus 41n minus 574. So these are the factors of 3 into 574, where 3 can be easily taken common from, or you can say 3n can be easily taken common from the first 2 terms, resulting here n minus 14. And here 41 can be taken common, resulting here n minus 14. So we obtained here 2 possible factors, n minus 14 and 3n plus 41. So on equating each factor to 0, it results here the possible values of n. So when n minus 14 equated to 0, it gives me here the value of n equal to 14. Next, when I have 3n plus 41 equated to 0, it results here the value of n equal to minus 41 upon 3. Now here n represents here number of term, and number of term cannot be negative and it cannot be in terms of fraction. So here clearly this cannot be the value of n. So only one possible value of n is here, that is 14. But in this question, we don't need to obtain value of n, we need to obtain value of x. So this question doesn't end here. Next you need to obtain value of x. So you could write here from equation 1. From equation 1 we get that x is equal to 3n minus 2. Now substitute here n as 14. So you will get that this is 42 minus 2, resulting the value of x as 40. So here we get the required answer for this question. So we have obtained the value of x, which is coming out as 40. So this is the required answer for this question. And this was a 4-marker question, where in this case, when you have considered this to be an AP and you have considered first term as A and common difference D as 3, you get half marks till this step. After that, for considering n terms of this AP and obtaining the value of x in terms of n, you are going to get half marks for this step. Then considering the sum of n terms on the left hand side and substituting here the formula of sum of n terms of an AP, you get half mark. Next, for solving this quadratic equation, which is a difficult one, and factorizing it properly, you get here 1 mark. Next, for obtaining this value of n, you get here half mark. And after that, to get the value of x, which is 40, the final answer, you get rest 1 mark for this question, which gives you total 4 marks for this question. I hope it is clear to you. Now let's proceed to our next question.